The super alignment plays a major role in the design within 12D. It allows IP-based design as well as element. To aid in the solving of your super alignment, which can be quite complicated in some cases, V11 has a new part called marker. Here we have an alignment made up of fixed lines and free arcs. The new marker part can be inserted at the end of the list. By moving the marker up, 12D will only solve what is above the marker, or if you do have two markers, only what is between them. As you can see here, if I position the marker above the last fixed line, it is not included in the solution, and as a result, the free arc fails. As I move the marker further up, you can see that the alignment solves, and when it does not. This is a great tool for analysing some very long rail alignments, for example. Design speed tables can be applied to your alignment, enabling the automatic application of super elevation and widening. Under Properties, we select Design. This alignment has a design speed table set with a speed of 70 km an hour. Once you profile the alignment string, you can see in section view the super elevation and the widening. The values shown are extracted from these design speed tables. Under Urban Road, we have set the default speed and the normal approach road crossfall of -3%. If we drop down to the 70 km an hour specified on this alignment string, we have a list of the radii available for 70 km an hour, the super elevation rate, the runoff value, whether there's a transition involved or not, and the minimum length of the curve. In V11, in the section profile, the design speed that's set on my alignment string, in this case 70, is now shown as a profile brown string line here, and if I hover my cursor over that position in my coordinate box down here, I can read a height of 70, which reflects the design speed set for that alignment string. The complete widening for your road is also shown in the section view. A feature of the super alignment is the option to customize parts on the string in relation to super elevation and widening. Here we're going to look at part number 6, the free arc. I select Edit Custom, Insert, and select the curve. The type of options we have is to change the speed for that particular curve, to do a more extensive manual calculation on that curve in relation to design super and runoff lengths, and also to ignore. If we change to speed and type in a speed of 60 km an hour for this curve, where the default is 70, we can automatically see a change here on our profile for our design speed for that curve now set at 60. If we go back to ignore and set, then the super elevation and widening is ignored for that curve. V11 now has the option to make those particular changes or customization to your alignment string to be inactive or active. We can now return to our main menu. The next V11 option deals with the issue of changing this element curve radius to one that may suit the existing road features. But with the radius I choose, will it be valid to suit the design speed of 70 km an hour? Previously, you would have to open the design speed tables and check. But now V11 offers a link between the radius box here and the design speed table values. You can select from the list, type in a value, but at least you know what the minimum value for 70 kilometers an hour was. V11 also has a new horizontal part called a free connection. Here we are wanting to join a fixed line on part number 1 to a fixed line on part number 2 in an easy fashion. The new free transition option called connection is shown here. It simply draws a connection between the last point on this fixed line and the first point on that fixed line. These options are available under transition free, and the choices are connection as we've shown here, chamfer and corner. If we select corner and we give an approach distance of 50 and 35 and set. So now this distance on the approach is 50 meters and the distance on the departure is 35. The last choice was chamfer. This has a deflection angle, so it could be used in trunk mains to allow a deflection here of 45 degrees. With trunk mains and water mains in mind, the V11 alignment string can now have a diameter set as shown in our section view here. Under properties, we simply go down to pipe. One of the new features for IP design is the ability to be able to lock our vertical IP to a horizontal IP. Here we've got IP number 3 in our vertical locked to IP number 2 in our horizontal, and a similar IP number 4 in the vertical locked to IP number 3. This enables us to have a deviation, in this case underneath a road surface, and lock in the X, Y and the Z for that IP point. If we now select move and adjust the IP point in the plane, we can see that the vertical IP is moving as well. In this session we're going now to look at the components. The components are trying to design roads, but also V11 has a new list of toolbars, and part of that, one of those toolbars is components. Components were introduced into 12D in a large way in version 10. Under our library list, we have examples for major and minor roundabouts and intersections, left turns, cul-de-sacs, right turns. We even have exit and entry lanes for highway work, bus bays, and the new Hammerhead. Before we have a look at the new Hammerhead, we will recap briefly as to what is available now and how easy they can be placed and manipulated to suit your geometric layouts. Here we're just going to place a component at the intersection of these two roads. The component we're going to place is a minor intersection, requires a major road and a minor road in this case. We can change a few parameters here, but the edit definition option allows us access to a lot more parameters. The major road highlights, the approach section highlights, and the departure section. For the minor road, we only have the departure. There is no approach on this side. is the placement parameters that are on the front panel. And we can change those. We're changing the distance here for our departure as we only have a simple curve. And again for the minor departure, we only have a simple curve. If we look at the minor departure, and the left-hand type curve, it is a stand-up curve. If we drop down to the curve option, the choices are fillet, a 2-center curve, and a 3-center curve. And again, all these values are able to be changed. We can adjust the carriageway widths and the number of lanes. We can also go a lot further, just a simple turn. If we go to the approach curb type here, so instead of having a stand-up, we can change this to either a free or a high entry curve. Let's look at the high entry width on our alignment string and make our traffic island larger. We can increase that to 8 meters. That resultant change of that value of 8 meters has now an error showing here. It's not an error as such, it's the fact that the taper is being forced onto this radius curve here. So the geometry is a valid geometry, but not one that you would expect. If we simply change the parallel length, which is the distance from here to the taper, and drag that taper off this curve, and again as we do, we get a valid solution. If you did want that taper on that particular curve, then you may have to do some manual adjustments to this alignment string and possibly have a large decreasing curve rather than a taper. Set and finish. If we now look at a typical placement of another component, and that would be a roundabout. So we just select the minor roundabout. Again, we pick our major road and our minor road. These values here are the length on the approach and departure, so we'll change those to 50s, which would suit the roundabout. Again, edit definition allows us access to more parameters. Again, if we expand out the tree, we can get familiar with the major approach, departure, and the minor approach and departure. To start, we can go to our placement, our center, and we can adjust the center radius. Here we're going to adjust the radius to 10 meters. For all 4 legs, if we go to the approach curve profile, there are several curve choices. In this one here, we have 3 tangents, straight, the width, and the circulating arc, and the next circulating arc and width and the departure road offset. Choices, 3 tangents arc, similar to the one previously, a fillet, a 2-center curve, and a 3-center curve. If we select the arc, 3 tangents arc, again, we may not get the solution that we're after. This is a tangent, tangent, tangent here to these 3 elements, and then a fillet. So these fillet values here may have to be adjusted to suit. We'll set that back to the previous 3 tangents locked arc. There are some circumstances where a roundabout doesn't have 4 legs, it may have 3 or 2. So we change the minor approach to 0, this leg disappears. So again, if we go back and look at our curb structure, we're looking at this curb structure here. So if we do change the curb type, again, we can change it to the 3 tangents and the fillet and so forth. But the last one we showed, which was the arc 3 tangents arc, does actually need this second leg in order to solve. So if you do pick something like that, and you don't have that leg, the output window will then tell you that your configuration is not possible with that particular curb type. So again, if you change it back, your solution will then be valid. Go back in place, our 4th leg on. Again, set and finish for the roundabout. We have some cul-de-sacs placed here, but we're also going to place now a cul-de-sac with an offset. Again, place component, select your cul-de-sac, the alignment string and which end. In this case, it's at the end of the alignment string. Again, we can edit the definitions. In this case here, we're looking at the cul-de-sac itself and the bulb radius, or the bulb offset. So we increase that to -5.5 and we get a complete bulb offset. That's some of the in version 10, and just a brief explanation of the value and the ease that they can be edited. Now look at a place component and the new V11 Hammerhead. Again, we select an alignment string, and is it the start or the end? The hammerhead itself, looking at the length of the hammerhead, so we can adjust that to the left hand side, and again also to the right hand side. We can adjust the approach and departure, or the left and right width of the road, and if our situation deemed, we could have a 45-degree bend in our hammerhead. If we decided we did want a radius there, we can put a radius in this position here. The components utilize reference computators where applicable, which allow any alignment strings to move and the components to update. If we edit our alignment string here, which is an integral part of the roundabout, plus the 2 cul-de-sacs, V11 now automatically adjusts every other super alignment or component that is linked to this alignment string. If I select move, grab my IP point, and I can adjust. As I adjust this around, it's automatically updating every component or super alignment that's referenced to that string without the need of a chain to do so. This is a feature that's available for every alignment string, and it will search through and find strings that are referenced to it and automatically update them. In this case here, if I go escape, and I create the alignment string, I would then have to adjust these components to suit that because I never finished the actual operation. So in that case here, I'm just going to do a recalc, which recalcs the component, recalcs that component, and again recalcs that. As you can see, the new features in the super alignment in version 11 are there to help you in your design. Thank you.